Before we begin, just a reminder, those are the formulas that you're using from grade 11. Okay, so we have B bar equals D over T, B bar equals VI plus VF over 2, delta V equals VF minus VI, and A equals delta V over delta T. And yesterday we went through miles to go, 2 ants, and our friend Melt in your mouth. Today we just have a boring old rock. I should come up with a weird name for the rock, or the guy dropping the rock. A rock is dropped from a cliff. What is its instantaneous speed after falling 2.5 seconds? I don't know what that is. It was some kind of cool picture I saw, so I put it on there. And how far does it travel in that 2.5 seconds? All right, so I had a few people ask me yesterday, what is this instantaneous speed after falling 2.5 seconds? Well, what I mean is this, right? The rock is dropped, and after 2.5 seconds, what is its v-inst? What is its speed at that second? Well, really, we're talking about the final velocity after 2.5 seconds. Okay, we're solving for the VF. What is the initial velocity? It's 0. How come? Because it's dropped. And we have the time too, right? The time is 2.5 seconds. Now, I had a couple people yesterday try this and say, Mr. Bennett, I can't seem to get this to work because I need one more thing. And there is one more thing because it's on Earth and it's gravity. Exactly. Acceleration is minus 9.8. So a reminder that when you drop things, the acceleration is pretty much always minus 9.8. That's an 8. Poor. Okay, so we've got A and we've got T, right? So A equals delta V over delta T. We're solving for delta V. The time is 2.5. How do you solve that problem? You multiply. So that's 9.8 times 2.5. 24 point something? 24.5. That sounds right.
Must have missed the numbers.
9.8 times 2.5. So the velocity changes by 24.5, right? Okay, well, we want to know the final velocity, so we're going to go VF minus VI. It's going to be, right? Because the initial is 0, so therefore the rock is falling at 24.5 meters per second. Oh, I know what I should do. I should change this question. So instead of it says a rock, I should change it so it says the rock. He'll be standing there buttoning his sleeve like he always does.
Like, hey Siri, what am I going to do?
Fixing his watch.
If you change it,
The rock is dropped from the cliff.
The rock.
He gets dropped off the cliff.
Yeah.
Doing his own son.
Yeah, to his own son, exactly. Maybe he's walking down, adjusting his watch, and he's not paying attention. He falls off again. Yeah, oh, I would. Okay, now, does anyone remember this one from last year? How much fun it was? Oh, did I? Oh, how far does it travel? Okay. Okay. So part B, to get how far, you have to find the average first of all, right? So we're going to go V bar equals VI plus VF over 2. Initial 0. Final is minus 24.5 all over 2. That means the average is going to be minus 12.25.
See, I did like that was 9.6, so all my things are
Johnny.
0.2 off all that. I was wrong. Yeah, I was like, Riley, what's the gravity? It's like 9.8, like
Negative
9.8.
9.8. Pretty sure it's 9.8. Nope, it's not.
Negative 30.625.
Thank you. This one needs a battery. Gotta get batteries.
Do you ever want to
Say again?
Do you ever want to round? Like if there's three decimals.
3, yeah, you can round. Yeah, two is more than enough. How much did you say, Talia? Minus 30 point what?
625.
Yeah, 6.3.
Look at how I've got minus 30.
It's the steps that I'm most concerned about, right?
Yeah, I did.
Remember when you
Yeah, that was fun, wasn't it, Talia? I gotta have that discussion with Mr. Ray about this truncating. Hey? Really?
He said round, you can truncate, but he said I was the truncator.
Because it's so hard to figure out how to round?
Yeah.
It's so easy, you just cut it off.
So you're telling me that you're not capable of rounding. You're in grade 12 physics. I can't figure out rounding. It's way too complicated.
I understand Terry's side of it because every teacher wants you to round different students.
Yeah, like staying around, this is you lay out the full thing.
You honestly should just talk to Mr. Ray and just kind of switch it, and we all do the same.
Some
Because
teachers
it
want.
seems more important for you because it's like.
Yeah.
Yeah.
My rule is I just want to see steps. All right. Well, let's round that corner and we'll get right into. So the bullet goes up and then it comes down. Oh, by the way, did anyone see there was a sheriff's office in Florida? They were tweeting out a warning to the residents when Hurricane Irma was making landfall. Please do not shoot at the hurricane. It will not, deflect the hurricane away from your house. Yes. Because that would be what you would think. Oh, I'm going to just, get the shotgun out and shoot that hurricane. I'll show it.
That'll work.
Yeah. All right. So it says 8 seconds later, the bullet has reached its maximum height. So that means that this flight is taking far more than 8 seconds. I guess, in fact, it really wouldn't be, it would be up and then down, right? What is the bullet's initial velocity? How high does the bullet travel? So we're looking for the VI, and we're looking for the distance. Now, so VI down here, right? The VF for that interval is 0, right? The VF for that interval is 0, and the time is 8 seconds. Okay, so we want to know what the initial velocity is. VI, VF. Okay, so and remember, it's on Earth, right, so A is equal to minus 9.8. Okay, Johnny and Jeff, this is going to have to end. Because I know how it's going to end. It's going to end with, I don't know how to do this. And it'll be because you do too much visiting in class. This is just a review so far, okay? Pay attention. A equals minus negative 9, delta V over delta T. So the A is minus 9.8. We're going to solve for delta V, and the time is 8, right? So multiply. Where is that? 78.4, I heard someone say?
But it's not negative, it's negative.
Yep, negative. $78.4, which means then that delta V is VF minus VI. So the change in velocity is minus 78.4. The final is 0. We're solving for VI. So in other words, the initial velocity then is 78.4 meters per second. That's pretty fast. And to get the height, again, to find the height, we're going to have to use the average. Well, we don't have the average just yet. Right? That means the average is 39.2. No, the initial is positive, right? It's going up, Josh, so the average is positive, right? It's going up, so the average is positive. Now we're going to multiply that by 8. 313.6.
Negative 9.6.
9.8, John. That's pretty high. Well, I mean, right?
That's a bullet.
I don't know. How high would a bullet go? I mean, I don't know how accurate these are. No idea. Right. What would be the muzzle velocity, Brett, of say a 22? No idea. What's the range of a 22? I'm very serious.
Yeah. Yeah.
I mean,
How, effective range or the?
effective range, so just how far is the straight line?
Yeah. How far would it go?
If you were trying to hit something.
You're just firing it in the bush, yeah. Or in a field.
Like this. Like if you're, like if you're.
Yeah. 200 yards is still pretty far, isn't it? Right? Because really, what's the only thing that's stopping it? Just because it's falling to the ground, right? Yeah. So in other words, it travels about 200 yards without really dropping too much, is what you're saying. Yeah. Okay. All right. So I've done 2 samples there. You should find that this problem sheet is relatively easy. The first one. I've got one more for you. Another problem sheet. So what I'm suggesting is, if you're finding, can I go on? If you're finding these ones are a little bit too simple for your needs, because it is review, you should be challenging yourself. If you find those too simple, move into these ones, okay?